All right. I don't have this uploaded into the smart board or whatever that thing is called. Where's my pen?
How do you know you do that?
Right here. Nice call. All right. Here's what we got. We got application questions when it comes to our formulas. Now, application just means a little bit of real world is sprinkled in. Remember our formulas. S equals R theta. And A equals 1/2 R squared theta. And these formulas are radians only. So if we ever see any degrees, you gotta hit the panic button and then say, oh yeah, actually it's not that bad. Just convert it into radians. Those are the formulas, nothing new. Everything that there is what we did last week. We already know that stuff. So question 1, it says Abby baked a Dutch apple pie in a 9-inch pie pan. She cut the pie into 6 equal slices so that everybody gets the same sized piece. How nice of Abby. Abby's baking pies. Maybe she's from the 40s or something. We like baking pies.
Yeah, that's not no young either.
Your grandma might be from the 40s. Here's where we're at, right? We bake a pie, we cut it into 6 slices, we're in good shape. Now, determine the central angle created by 2 pieces of pie. This should be an easy question. Determine the central angle by 2 pieces of pie. So that would be 2 pieces of pie. You could add those together if you could figure out the central angle of 1 piece of pie. And this should be relatively easy because we have 6 evenly divided slices. And how much would all the angles add up to? 360, of course. And so the angle should be 360. But for us, we divided it into 6 pieces, right? So for us, we divided it by 6. And that would mean that theta is equal to 60. But that means that each theta is 60. And so question 1, which says 2 pieces of pie, would be how many degrees? 120. Now, what if they wanted that in radians? 2 5/3. And that is actually kind of nice and kind of easy. Remember, this is 1 pie is actually half of the pie, right? I mean, we're really cooked in trig right now, but you get the idea. And we have 2/3 of that pie. But anyways, question number 2, it says determine the area covered by each piece of pie to the nearest 1/10 of a square inch. That means that we're looking for this area formula. It says we're doing 1 piece of pie, so we're going to use 60 or pi thirds. But what are we going to use for our radius? 9. Now it says Abby baked a Dutch pie and apple in a 9-inch pie pan. 4.5. Yeah, so that 9 is the full, so you're exactly right. So here's our formula for the second question. This should be pretty easy. Area of a slice should be area equals 1/2 R squared theta. Should be area equals 1/2 4.5 squared, and theta is pi thirds. You go in the calculator. It doesn't matter if your degree is in radian mode or degree mode. The only time that matters is when you press the sine, the cosine, or the tangent button. So don't have to worry about any of that stuff. Let me grab a calculator. Anybody got an answer for that? You got it? You say 10 or 2? 10. 10.125? And it says to the nearest 1/10 of a square inch. So I'm saying area equals 10 point, you said 125?
Yeah.
So I'm going 10.1. And it says square inch, so I'm gonna put inches squared.
Wait, it's probably. I got 2.6.
Oh, I knew it was.
Wait, did I not have this right?
I got 2.6.
They just Oh yeah, we're gonna act like
We goofed it a little bit.
yeah.
0.5 parentheses 4.5 squared times alpha y equals pi over 3.
Yeah, 10.6, bro.
Okay.
10.6?
Yeah.
My bad.
10.6, 10.6.
The half of
4.5 is half of 9, and 9 was in the question. They said that she bakes a 9-inch pan, so we cut it in half. Alright, we've got 10 minutes till lunch, and we've got basically just 2 more quick questions. Next, Susie baked a similar pie, but did not necessarily cut it in the same manner.
God.
If a piece of pie had an arc length of 9 pi-8ths, is Susie doing the most or what, right?
Yeah.
But I don't know what I'm doing, but I'm just trying to be cool. Alright, cool. We hate Susie. Susie baked a pie. Alright. Susie maybe didn't cut it into 6. She had an arc length of 9 pi-8ths. What was the central angle for this pie? Well, 9 pi-8ths. I don't even know. Maybe it's something like that. It says that she baked a similar pie, but just didn't cut it the same. So I'm gonna assume it's the same radius, I guess. Honestly, I don't think this is explained very well in the worksheet, but I guess we can assume that this is also a 4.5er here. So our arc length formula, S equals R theta. Our 9 pi-8ths is the S, which is the strange word that they like for arc length. The radius is 4.5, and theta is what we're trying to figure out. Now we're gonna go ahead and, divide both sides by 4.5. And we can do this in the calculator. A couple different ways to type this in the calculator. You could press alpha y equals enter, to put a fraction on top of a fraction if you wanted to go about it that way. You could also use parentheses, or you could just use the divide symbol. Now I got a number 0.785. Is that what we got?
Yeah.
Okay, now that doesn't really seem like a very good answer, but this is theta, which is the angle, but it's not in degrees. This is in radians, and radians are normally fractions, somewhere, around 1 or something like that. And so I think for this question we could say theta equals, does it say how to round for this? Not really. So maybe we'll just give it 3 decimals. 0.785, and then I'm just gonna add radians on the end there. Because it might not look like radians, so when I write radians, but okay, maybe that makes a little more sense. Now, the reason that we get all of this decimal is because in the calculator we typed a pi, and as soon as you put a pi in that calculator, you're going to get a decimal guaranteed. So actually, another way to write this answer is if we go back to the calculator, just delete the pi, hit math, enter, in order to turn it into a fraction. What we get is 1/4. Now that pi that we deleted, we get to hold on to, so we can write it right there. And so Susie, who seems to be annoying and making this random, 9 pi-8ths, arc lengths, whatever, actually cut pi-4ths radians for each of her slices. How many slices would she have on her pie?
25.
Car isn't one of those shout random numbers kind of videos, but that's okay.
Eight.
It's a Monday. It would have 8 because it would be pi-4ths and then pi-halves and 3 pi-4ths and then pi and then boom, boom, boom. Susie cut her pie into 8 slices. And that's how she got all of this. Again, if you were following along with us here, and then all of a sudden I lost you for this last piece, here's what happened. We typed in pi, so we were gonna get a weird decimal. What would happen if we didn't type in pi, and we just saved it for later, since that's how we like radius to look anyways. Very last question here. Determine the area of the piece of pi to the nearest square inch. Well, this should be quite easy. The area formula, and then we're pretty much done. Area equals 1/2 r squared theta. Area equals 1/2 4.5 squared, and theta, we can use either one of these. I guess pi fourths is a little bit more exact because it's not rounded. And would anybody who didn't get the question wrong last time like to say anything? I got 7.952 as well. They said determine the area to the nearest square inch, which means no decimals. So I'm going with the area is equal to 8 inches squared for that second piece. So here's what's going on. Applications of the things we already know, which is just basically instead of telling you circle, they tell you pi. Or instead of telling you circle, they tell you a puddle of water. Or they tell you a baseball field that is kind of like the quarter of a circle. So applications, no new mathematics at all, just giving you some pictures.